Okay, hi everyone, and welcome to this ninth edition of Cyber Jagrookta Diwas. This is an event that we've been now organizing for past 8 months. This is the ninth iteration of this talk. Today we have with us Mr. Saurabh Kumar. So just a brief introduction about Saurabh. So Saurabh is a PhD candidate at the Department of Computer Science and Engineering, IIT Kanpur. He's currently working with Professor Sandeep Shukla at IIT Kanpur and Professor Biswardhan Panda at IIT Bombay. His research interests include cybersecurity, Android security, malware analysis, cyber forensics, etc. Before joining IIT Kanpur, he served as an assistant programmer with the Central Bureau of Investigation. And during his work with CBI, he actually worked with cyber crime and cyber forensics. So essentially, he has a very vast practical knowledge set that we can probably be benefited from. So without wasting much time, I'm just going to hand over the podium to Saurabh. Saurabh, over to you.
Thank you, Saurabh. So, I think hello everyone. Today I will discuss about the mobile security and more specifically to the Android platform. So let's see why someone will be worried about the mobile security or why we are mostly focusing on the Android platform. So first question is why mobile security is needed? Because the users are more active on a mobile device rather than desktop laptop, which is the response rate to a query. For example, whenever any email or any message comes, and user can respond immediately. It also contains valuable data like contact details, photos, or sometimes bank account credentials, etc., which can be an important, which can be once someone can be interested in this information. Another factor is that it is remained power on for the maximum time, which helps in answering a phone call on a real-time basis, which also attract a malware writer or any attacker to infect a mobile device, which can be used in a mass attacks like DDoS. Another factor is that it is open to multiple attack surfaces through which an attacker can infect a device. For example, its interaction with the cell tower to facilitate the incoming calls or outgoing calls. Another factor is that it can connect to a corporate network if someone is working in that organization. If his or her mobile is infected with malware, it might be possible that the organization infrastructure will also be compromised. Another factor is it communicates with the multiple websites or applications. So any one of these communication party can turn into a malicious activity, which can infect the device. For example, an attacker can mount a fake cell tower IT, a fake cell tower to infect mobile device. A phone device can be connected to this fake cell tower ID. Next, let's see why we are focusing on the Android operating system and why not other mobile operating system like iOS, Windows, etc. Because it is completely open source based on the Linux operating system, and the global market share of the smartphone. A report published by the IDC Corporation shows that in the year 2020, Android share in the global smartphone market was 84.1%, and they predict that it will capture 84.9% share of a smartphone market by 2025. This results in more attacks by attackers on Android device as compared to the other operating systems. Another factor is the involvement of multiple entities in the Android ecosystem. So multiple entities means that there are multiple persons are involved in a Android ecosystem, such as that the Android operating system is designed by the Google, which is further customized by the device vendor like the Samsung, LG, Sony, and other, etc. An app developer can develop, any person can develop an application by using the tool chains such as Cordova and App Generator, and they will submit their application on a mass market like Play Store for wide visibility. So any one of these entity can turn into a malicious activity and malicious entity, which can infect your mobile device and can exfiltrate your important informations. As you can so this is the security impact of an actor over others. For example, if a OS developer is malicious, it can compromise library providers, software developers, and other factors, but it cannot partially compromise the hardware vendor, because hardware vendor generally customize this operating system. So these are these factors which can be influenced by the one actor can influence the other actors, right? So where we can improve the security. So one is this app developers, then which says that usable security means we can make aware app developers aware about the security principles, the list security principle which can be incorporated at the time of designing an application. Another place is the marketplace, where we can deploy a security system to analyze application for the malicious intents and give a clean sheet when they find that it is not malicious. And there is the installed applications. So or we can say that application layer security monitor, which is inline reference monitor, where we can deploy a antivirus engine on a mobile device to detect malware or monitor the behavior of an applications. And there is the can be done at the security can be improved at this Android operating system level itself, right? So with this motivation summary, the feature-rich smartphones and amplification have induced security researchers on various new aspects, like that there are more users are more information are available at the smartphones, so security researchers are more influenced with this smartphones. Either the open source nature, which has made Android very attractive to the security researchers because it is open source. So anyone can study each and every component of an operating system. The number one share, the market share of Android has made Android the number one target for malware authors and the cyber criminals to gain some to perform some malicious activity. And another factor is the various actors in the ecosystem, which has strong influence on security and the privacy. Like if an operating system designer is malicious, then he can compromise entire mobile phones. So let's see some background, brief background of Android. So Android is generally contain the 4 layers. Now one layer is also introduced, which is the Hall layer, which comes just above the Linux kernel mode layer. So it is based on the Linux kernel. There is one Android runtime which contains 2 types of virtual machine. One is Dalvik and another is the ART. Another component is the native labs, which provide the native library written in C, C++ to perform to increase performance of an application. And there is the application framework, which provides the APIs to design an application. Other layer is the application layer, which contains the default apps and the third-party apps. The default apps are the apps that comes with the mobile device when we purchase, and the third-party apps are the app that we generally install as per our requirements. So let's see what are the application, what exactly an application contains. So an APK is simply a packaging format like jar file or zip or any tar file. It contains the 5 components. First is the component of an application, which is contained in this classes.dex file. It generally comprises of 4 components: activity, a visible screen through which we generally interact with an application, a content provider, which generally used to access data of other apps or provide facility to access to provide our data to other applications too. Services, it is the long running services, means any heavy processing task which does not require any human interference, then we generally use these services, like when we are uploading some GBs of data on a server, then we generally prefer that it can be stored in the services. Another one is the broadcast receiver. It is generally as a treated as a mailbox system, which generally from where we register some events. For example, whenever any incoming message comes, my piece of code just executed by taking this event, listening to this event. So this is called the broadcast receivers and do any things whatever they want to. Another one is the native code. An application can also be developed using the C++ code. And there is this resources which generally contains this graphics images, some strings or some data for which is necessary for this application. Another one is this meta information, which generally used to verify the integrity of an application, whenever this application is modified or not. Another one is the application manifest file. It is we can generally say that it is the heart of an APK. Using this file, we can say that this application contains this much of activities. This he can perform this task. This application can perform like access network access, can access GPS location and every other information. So all this information are registered in this application manifest file. So these are the basic component of this Android applications. Let's see what are the security features that Android provides. Let's first see the package integrity. So package integrity is based on the jar signer. So as we have already discussed that meta-INF stores the information about this integrity. So it contains the two files, manifest.mf, cert.sf, and cert.rsa or DSA. It is generally a public key of this signing certificate. So how these files works individually? So any individual resources like the IC launcher.png image, its hash is stored on this manifest.mf file. Then particular each and every resource is stored in this manifest file, manifest.mf file, and hash of these each and every resources are stored in this .sf file. So this is the two-factor hash, so that anyone is if someone has changed the hash or of one location, it cannot change the hash of the other locations. And this cert.sf signature is stored in the cert.rsa file along with the public key to verify this integrity. So how this integrity is verified? So PKI infrastructure, public key infrastructure. So package.certificate, the cert.rsa file is used to certify the cert.sf file, and the cert.sf file is used to verify the manifest.mf file, and manifest.mf file is used to certify each and every individual resources of the application. Unfortunately, this public key infrastructure is not available with this Android operating system. Means Android generally promote this self-signed certificate. So because of that, there are many attacks have been possible with this application. Means that you can just decompile an application, introduce some your code, and rebuild this application with your own certificate. So no one can identify that the application is modified or not. And there is the sandboxing. So sandboxing is referred to the sandboxing refers to the confinement of an application. Means that an application can perform only designated task which is allowed for that application. An attacker can only perform action defined by this sandbox. Okay. So for example, each application is isolated in each application is isolated in its own environment, and the application can access only its own resources, like if he which is available with this application. If they want to access resources of other application, then proper access rights are needed. which will be governed by the permission. Sandboxing is enforced by the Linux kernel using the user ID models. So for example, if an application wants to access internet and the corresponding permissions are not given to this application, then it cannot access the internet permission. So it cannot send any data to outside the world. So application, this is the application sandbox where all the classes.txt file and all the information is associated with this ART, and the native code is outside the boundary. But each and every application is assigned a unique user ID, which is generally used to enforce the security mechanism. Okay. So each app lives in its own sandbox. These are the snapshot of 3 different applications running in an Android operating system, which generally has different user ID. So whenever they want to access data of other application, but first the kernel, Android kernel checks that this proper right is provided or not, the proper permission is granted or not to access the resources of other application. If it is not, then it will just deny this information. And there is the permissions. So we are generally speaking more about these permissions regularly. So Android permission system. So and access rights in Android is provided based on this application frameworks. So permission are required to gain access to system interfaces like the internet, send SMS, etc. System resources like logs, battery, power, and all other information. Also the sensitive data like the SMS, contacts, and some other informations. Currently, more than 140 default permissions defined in the Android operating system, and also which is assigned to a sandbox. Also, an application developers can also define their own permissions to protect their resources from accidentally accessed by the other applications. This is an example where 3 apps are available: App A, App B, and App C. App A defines a service which is protected by the custom permission P. App B has this permission P, but App C does not have this permission. Whenever App V want to access this service, so it is granted to this application V because it has this proper permissions, but App C does not have. So it is designed by the Android monitoring framework, the security monitoring frameworks, that you do not have this access right. So we cannot grant you permission to access this information. So in Android, the permissions are defined with this 4 protection level. One is the normal. The normal permissions are the permission which generally does not related to some sensitive information. So like if one want to access internet access, so internet access does not belong to a sensitive information. So these are the normal permissions. One is the dangerous permission, which is generally related to the sensitive informations like the SMS, contact details, and other informations. And there is the signature permission. So signature permission and is generally granted to the application, other application, which is, suppose there are 2 application, application A and application B. Application B want to access some data which is protected by the signature permission. So in this case, Android verify that both the application A and application B are signed by the same certificate. If it is signed by the same certificate, then it is granted this permission. Otherwise, they will discard this permission to the application. And there is the signature or system permission. This is the work of this permissions is similar to the signature permission, but the difference is that the certificate which is here used to sign sign an application is generally related to the Android operating system certificate. Means that an Android operating system is generally signed by some certificate. So an application is signed by the same certificate which is signed by which is used to sign the Android operating system image. Then they can grant this permission to this application. So generally signature or system level permission are granted to the system apps, or we can say this is a default apps which generally come with the Android operating system of the which generally come with the pre-built devices. So one is the dynamic permission. Before the Android 6.0, the dangerous permissions are granted at the time of application install whenever we install this application. But from the Android 6.0 and above, these permission require access right during the runtime. Means that whenever an application want to access the data, it requests permission at that time. First, it requests that permission at that time, and user can decide whether he want to grant this permission or not. Also, an user can later on he can revoke this permission or can adjust this permission by using the settings. So these are the security features which Android provides. Let's see what are the vulnerabilities that can be exploited by any malware or malicious software or the attacker to gain some sensitive information. So these vulnerability we have classified in three categories. One is the architecture based, another one is the software based, and another third one is the hardware. Software based permission can be further classified in the three categories. One is the operating system, which is generally introduced by the operating system designer, which is the Google. Another one is the original equipment manufacturer. This vulnerability can be introduced by the device vendor, and the another one is the third party application, which generally developed by an application, and they leave this vulnerability inside their applications, which can be exploited by any other attackers. So let's see the uh, architecture based vulnerability. So generally we can say that this is the application level privilege escalation, which comes with the architecture level exploit. So these can contain two types of attacks. One is the confused API attack, where one malicious app can confuse to other non-malicious application, which is designed by any third-party vendor and can perform some malicious action by uh, and trick this benign application to do some malicious action on behalf of this malicious app. Another one is the collusion attack, where two malicious apps combine their permission to perform some malicious actions. So let's see the collision attack, how this works. Suppose there are two applications, app A and app B. App A has internet permissions and app B has SMS read permissions. Okay, so SMS read, the app B first access the SMS from the Android operating system. Android operating system check that these permissions are available with this and malicious application B, and then they provide the SMS to this as a response to the application B. Application B transfer this information to application A, and application A eventually leak the information to the other word or the any server. So this generally happen when the two malicious application pollute their permissions or merge their permission to perform extra privileges. So variants of this application can be, they can directly communicate by creating some shared channel or shared communication channel, or can communicate via covert channel. Like suppose both application has some protocol decided that at particular time, if I am doing some intensive work, then you just identify the time, sending you information 1, otherwise 0. So these type of attacks can be performed using the collision attacks. And there is the software based vulnerability. So software based vulnerability, first is the dirty cow. So dirty cow bug is existed in the Linux kernel for 9 years. So it is a local privilege escalation vulnerability, and it exploits a race condition in the implementation of copy on write mechanism. Copy on write mechanism is that whenever we want to write on any read-only page which is shared with multiple processes, then first you will copy that data into another page and then perform write operations. Using this vulnerability, anyone can turn a read-only mapping of a file into a writable mapping, which can provide a root access to an application. So this bug is introduced. This bug is discovered in this 2017, and September 2017, one malware is exploiting this vulnerability to perform malicious action on this Android platforms. So this is the Linux kernel-based vulnerability, which is generally related to the operating system. And there is the media projection service issue. So what is the issue is that this issue related to the media service, which facilitate the screen recording or screenshot. An application can capture a screen or can record audio, even record entire screen without the knowledge of the any user. This vulnerability is discovered in the 2017 also, and this is vulnerable till Android 7.1. And there is the overprivileged apps. So this is generally happened because of this third-party application or the novice app developer, which does not know that which permission is actually needed for their functionality. So they just randomly include multiple permissions to over limit or overcome the crashes because of the permissions. So suspected root cause for this is the API documentation and naming convention, which is not correlating to each other. That's because of that, the app developer can include app developer including the extra permission which is not required for these applications. The solution for this is very easy. So anyone can provide a mapping to this permission with the API, or which can be implemented in the lint tool. Generally the IntelliSense API things that if you are using this particular API, just include this permission to your manifest file. Otherwise, no need of that. So this can be easily mitigatable. But because of this overprivileged apps, the confused FT attacks is happening, where the privileged app, which is which is benign, is fooled by this unprivileged app, malicious app, to perform some malicious activity on behalf of this malicious app. So example of this is the unauthorized phone calls. So it has been seen that many application which does not have a phone calling facility, but they are exploiting some other application to perform this task. Also, these confused FTs are also found in the system apps. Means that the device vendor is also not aware about this permission system, that what permission are actually I am going to implement or not. So these are the some example of this Samsung device, which generally in which one the Samsung device firmware where some confused FT has found, in which one confused FT is running with the system privilege, which providing the root cell services to the any application. If suppose if any app in getting root privileges, then he can do the application can do anything with the mobile devices. So these are the software-based vulnerability. Let's see some hardware-based vulnerability, because the hardware is also designed. So some vulnerability will also remains with the hardware. So one example for this is the Broadcom Wi-Fi SoC flaw, where there is a buffer overflow vulnerability, which is providing the access to this privileged access to some application. So generally, the SoC is running at the lowest level, so it has the higher privileges, and it is not infecting only Android devices, but also this iPhone and all other mobile devices. So these are the some vulnerabilities. Let's see some advanced threats which can be exploited by the, which can be introduced by the as a functionality by the Android, but can be exploited by the attackers, or some new vulnerabilities will be introduced because of that. So one is the dynamic code loading. So dynamic code loading means that any application can load some external code, or which is not the part of the application at the runtime. So these are some techniques, the class loader, package context, or native code, which can be used to perform this dynamic code loading. So Dex class loader is the API which generally used to perform this dynamic code loading of the Dex code. The risk is related to the no checking of integrity of the or authenticity. So any application can downloading at the runtime, so you do not aware about this thing. So because of that, attacker can control loaded data, which can be of any type, whatever they want to. Similarly, the package context. So these are the some risks associated with these techniques, and what attacker can do with these things. Another factor is the Android stand app. It is introduced by the Google, so that if suppose you want to mm, purchase some application, but before purchasing application, or before installing application, you want to take a trial of that. So the Android comes with the instant app facilities, through which you can access functionality of an application without installing it on your device. These applications are also like the native application, like all other application, work fine, but it generally runs within link. So you have a one link, and based on that link, you are accessing this application. Whenever you are just using this application, or you are familiar with this application, you can just install this as per your needed. So this is introduced in this 2016, and May 2017 they has released the SDK, so that anyone can develop their instant applications for their organization. But before releasing this application, one phishing attack has been performed on this instant app. So anyone have the link which is genuine looking, the app is looking like a genuine, but that this link is related to the some malicious locations. So users are accessing malicious application as because in comparison of this benign application, which is generally required for this application. So these are the new threats which comes with this Android application. So these are these exploits and the threats that can be exploited by a malware. So let's see what are the malware analysis techniques and what are the limitation of their limitations. So first, see why we do malware analysis. So basically, so there are some newses that the data stealing Android app malware infiltrate the Google Play Store and infecting the users in 196 countries. Means that the Android Google Play Store is also having the malwares. And there is the several popular beauty camera apps caught stealing in user in photos and uploading on a server. One is the crypto hijacking, clipboard hijacking malware, which is generally whenever we just suppose you are sending some money to a Bitcoin money to some Bitcoin user. So generally this is associated with the account a long hash value. The account is associated with a long hash value. You generally not remember that account. So what you do, you just copy this account number, means the hash value, and just paste to the application to send this money. So this malware is exploiting this clipboard. So in the meantime, you have just copied this information in the clipboard. The malware is changing this information in the clipboard, and at the time of pasting the paste pasting this in the account information, you are going through the wrong account information. So the money is transferring into the wrong account. This is a recent one thing, which is related to the banking malware. So hitting more users than ever. So if malware is exploiting banking information, which is related to the financial loss. So generally we are using mobile phone and do all the banking transaction in our mobile phones only, mostly. So this malware can exploit this too. So the malware not only perform financial loss, can also perform a image, defame you by exploiting some the leaking some sensitive information, your sensitive information to some other servers. So the consequences because of this malware vulnerabilities and all other information, and not becomes the first target of malware writers. A report published by this AV test shows that in the year 2021, around 3.39 million new Android malware were discovered, which shows that every 10 seconds, a new Android malware is born. So in this pace, is with this rapid growth, there is need to trim down this growth by using the malware analysis. So we need to perform malware analysis. So malware analysis techniques is broadly classified into three categories: the static analysis, dynamic analysis, and the hybrid analysis. Hybrid analysis is the combination of both the analysis, both static and the dynamic. In static analysis, we analyze an application without executing it, whereas in the dynamic analysis, we execute an application inside a control environment to monitor its behavior. Using these three techniques, many work has been proposed that are using these techniques to analyze an application, which can be deployed either on a server machine to analyze application offline, like the Google has deployed a Google bouncer, which is to detect malware on Android of Google Play Store, or they can be stored in a real device. Okay, a server generally has the unlimited resources, the huge capacity, huge computing power, and the resources. So it can perform both static and dynamic analysis. However, a smartphone has limited resources like battery power. So you cannot deploy a high resource requirement solutions, due to which we can only use static analysis techniques. Otherwise, if you use the dynamic analysis process on a mobile device, it will surely drain out the smartphone batteries. So offline analysis built around the dynamic analysis can be bypassed by detecting the emulated platforms, because generally we perform dynamic analysis on an emulated platform, or like the Camu based or the VirtualBox based. Also, we can observe the overhead, the system, because of that the systems slow down. The performance of the system performance is very slow because of this profiling overhead. And also an application can perform malicious activity in multiple layers, either using in Java code, the application framework, or the native code. So if we are targeting or profiling an application based only on single layer, then you cannot detect this malware, so they can evade this information. On a real device, we cannot use the existing offline methods because their resource requirement is very high, which generally drain out the battery of the mobile device. So we generally prefer some lightweight analysis tools that can be deployed on a mobile device. So these are the some limitations of these analysis techniques. Like the static analysis is suffer from the dynamic load coded. So dynamic load coded Loaded code generally not the part of the application, so it cannot analyze this application. And there is the crypto API. Suppose some data is encrypted inside the application, so you cannot identify what exactly this information is. And another is the Java reflection. It is generally related to this invoking functionality at the runtime. Right. So this functionality is generally visible at the runtime, and static analysis does not deal with this information. And there is a false positive if suppose an analysis system is designed based on only the permissions. So any application is using permission. So if application is using this permission or not. So based on this, false positive is generally used introduced with this static analysis. And the network-based activity. Suppose an application is performing malicious action based on the network activity, like the DDoS attacks. So because if it is not connected with the command and control server, then they cannot identify this malicious activity. Similarly, the dynamic code loading, it is having the dynamic analysis. It is having also the false positive if it is based on the anomaly detection. It has the code coverage limitation. Also, the emulation detection is one of the factor of this analysis, and also it slows down the system performance approx 10 times. So this system slowdown will generally reveal that an application is running on a monitored environment. By observing this slowdown, an application can easily bypass this analysis system. The another is the hybrid analysis. So it is depend on the data dependency, is the logic based trigger. These are the some techniques that can be bypass that can use to bypass this hybrid analysis engines. So these are the some tools that has been frameworks that has been designed to analyze application, like the Orasum, which is using the dynamic analysis and detect API misuses. So the limitation with this is the native code, because it is monitoring the information only at the framework level API. So it cannot analyze this information. Similarly, these are the separate application. This Drebin is a on-device Android malware detection, which is lightweight and static malware analysis system, but it does not analyze the colluding apps where multiple apps are colluding their permissions to gain perform more malicious actions. It can prone to obfuscation attack. It cannot analyze dynamic code or also not handling the native code. Some other information are also there. So these are the work that has been proposed, or the malware analysis frameworks that has been proposed, and these are the limitations of these applications. So where these analysis techniques are generally used or are utilized in the real world. So the static analysis, dynamic and hybrid, both are analyzed, used in identify the malware, grayware, and the vulnerable application to find the vulnerability in inside applications. So the static analysis is generally used, widely used, because it does not consume much time and it is very lightweight. So these are the statistics where these techniques are used on this malware analysis. So till now we have seen this, what are the analysis techniques and based on their framework. And now we will see the what are the main challenges in analyzing malware or the related to the Android security, and the future direction that can be focus on focus to design robust analysis systems. So one is the Android stand app, because it generally these components are installed on the fly. So these are having the most recent challenges. It is not touched by any other anyone in the analyzing the malware analysis. And there is the device fragmentation. So because Android is operating system, open source, so anyone can develop new devices or can customize their operating system. So they generally does not. So you have to design some uniform solution so that they can analyze these devices. Either the cheap devices. Cheap devices means there are new devices is coming every day. New vendors are coming every day, which does not have proper infrastructure to provide security system for this their devices. So we have to taken care of these devices too. Either the clouding apps. So you have to check that multiple applications can perform malicious tasks. So less work has been focused on this coding apps. So these are the challenges, real challenges, because you do not have any mechanisms to identify that which are the apps which are communicating with each other to perform malicious application. And the other one is the platform sensing malware, or we can say the emulation detection malware that can detect that they are running on an emulated platform or not to bypass the dynamic analysis system. So the work can be done on this. These are the challenges. So based on these challenges, these are the some future directions that can be performed. One is the basic simple app analysis to analyze whole system. Not only the simple application, you can analyze entire app system too, because it might be possible that the malicious action is performed by the device itself. Just this, because similarly the case with this latest case is with Lithuania government, which has identified with this Xiaomi Note 10 Pro that they are infiltrating some sensitive keyword to other Chinese government related to this. So similarly, the consider the dynamic loaded code that is not bundled with this applications, because any application can download external resources and then can execute these applications. And there is the analyze code of different forms from different language, like the native code. If your code is written, a malware is written in native code and the framework level code, then you can analyze this code. Also the obfuscated code. So malware structure remains same, functionality remains same, but the hash value and all the other information is obfuscated. So you have to taken care of this thing. So you can do work on this obfuscated. Another one is the colluding malware analysis and the stealthy dynamic analyzer. The stealthy dynamic analyzer means that you should design some dynamic analysis framework that is stealthy, which cannot be detected by any emulation platform sensing malware, or can perform cross-layer profiling, and also it can incur very little overhead. Otherwise, if it is incurring high overhead, then malware automatically detect this because of this overhead issue. These are the future directions for this work. So thank you. This is my last slide. So if you have any questions or any doubts, you can
So,
ask it.
any questions from the audience? So I had one question, Saurabh,
Yeah. Yes.
that I would like to understand. So basically, let us take the example of a permission like the access to the SMS text, right? Like whatever
Right.
text is there.
Right.
Um, is there any work going on where we can basically make these permissions more finer grained? So for example, I'm just curious. For instance, let us say I have Zomato on my phone, right? And the
Okay.
Zomato guys,
Right.
whenever
Right.
I do a payment, it requires an OTP which is sent to my phone, and then Zomato asks me, please allow me to read that
Read
SMS
SMS.
so that,
Yes.
and
Right.
I have to say yes, right?
Right.
Is it possible to, because to the best of my knowledge, what I understand is that the moment I give Zomato app that access to
Right.
read my SMSs, at that point of time, it can actually read any SMS, right? That is there in my
Right.
complete
Right.
complete dictionary. So any work, any apps that you are aware of which try to basically restrict the domain of these messages? So for example, is it possible to say, okay, a particular application declares that these are the kind of numbers or identifiers. If I have an SMS from these origins,
Right.
only those SMSs are allowed for my app to read, and not something in general.
So generally, right now, this type of permission or this fine-grained permission system is not
Okay.
in not built with this Android operating system. So this kind of work can be performed to analyze this thing. For
And
that, you have to
and any
provide
service
the
that I can, let us say, for example, a person like you could probably write a service which can is it possible to understand that which app is trying to access which SMS? Because then we can probably try to see that maybe it's Zomato, but it is trying to read the SMSs that was sent to me by my friend, for example. So is it possible to do some kind of analysis like this?
this kind of analysis can be performed if you have the higher privileges,
Okay.
right? Because the Android is mostly providing the restricted permissions. If you are sitting inside the OS system, then you
Got
can
it.
do these informations. Otherwise, it is
So
very
maybe
hard.
if you
If
collaborate
you
with
want to,
Samsung, for example, so
yeah, right.
Samsung can,
So we can do that. Or
right.
also you can perform, you can purchase some Nexus devices
Okay.
and customize your operating system based on that. Because Nexus devices are using the bare metal, the original Android provided device, and each and every component of this Nexus device is open source. So you can implement each and every thing on this thing.
Okay.
So at that time, can you
That
do?
makes sense. That makes
Yeah.
sense.
Or otherwise, you can perform, you can root your mobile device and use some framework like this expose framework or the
Yeah,
one
rooting
another
actually
framework.
has become a headache because I have rooted almost all my devices, but now the
Right.
problem is my banking apps won't work on it. My banking apps
So
usually refuse.
you can fool these banking apps too.
Okay.
By if you have rooted your phone, you just install the expose framework on that, and you
Okay.
just create your custom module based on this expose framework, and then
Okay.
you can fool APIs based on that information.
Okay, that was
Right.
something that I was not aware of.
Right.
So thank you, Saurabh. Any other
Yeah.
questions from the audience? Okay, so let me thank you, Saurabh. First of all, I would like to tell everyone that Saurabh agreed to give this talk at a very short notice. So thanks a lot for discussing these
Yeah.
things with us. And this was the 9th edition, guys, of CJD, and we will of course be uploading the talk on our YouTube channel as well. So let me thank everyone who attended this talk, and a special thanks to Saurabh. Let us hope that we hear from you again on some particular event. Right? Thank you, Saurabh. Thank you,
Right.
everyone who come
Yeah.
here.
Thank you. Welcome.